We're going to talk about design patterns. So this is general Java design. Design patterns predate design Java, however. They're used in multiple languages. They're a common way of representing reoccurring types of problems, right? So it's given this problem, how do we solve it? Well, I've seen this kind of problem before. This is a reasonable way to solve it. So I'm going to go through a few design patterns today. You can look at the Wikipedia page if you want. This book, it's probably a little advanced for you. I'm only going to go through, like I said, 3. There's 23 different patterns. You do not need to understand all of these patterns, okay? The important part is jump to the type. The ones we're going to look at are abstract factory, factory method, and command. There's a number of other ones. Some of them are more useful than others. These are, the 3 that are really useful for you in this course. And you can find tons of design patterns out there. There's, hundreds. But these are the classic design patterns, and this is the classic design pattern book. It's called The Gang of 4. Like I said, I don't think you're probably ready for it yet to read, but in the next while, you should find a copy of it and take a look at it. Or any book on patterns or any websites on patterns. They'll just improve your programming. So what I've got is I've made and I'll post all this code. I've created a little hierarchy here. So at the top of the hierarchy is a game character. Doesn't do much. And underneath that is a monster. Monsters have levels and they have types. So level is a thing you probably haven't seen before. It's an enum. And we're just saying that monsters can be easy, medium, or hard. And they have a level associated with them, 1, 5, or 10. Because I don't need to make that private. Just do it as a matter of course. So you can create it and you can get the level back from it. And the same kind of thing with the type. So we've got 3 types: rats, skeletons, and dragons. And they each have a name, right? Like rat, skeleton, dragon. And we can go from the name back to the type, which is a useful thing to be able to do. We'll make use of that momentarily. Sorry, I gotta blow my nose. I do apologize. So we've got the monster interface, and underneath the monster we have abstract monster, which has the level and type. And for skeleton, for example, it's a medium monster with a type of skeleton. A rat is an easy monster with a type of rat, and a dragon is you guessed it, hard monster with a type of dragon. I would probably add additional methods and variables and all that, but for this purposes of this, I don't need to. So the focus isn't so much on these classes as what we can do with the classes and stitch them together with these design patterns. And then we also have the player, which is also a game character. And it's got a name and a level, and its level can change. The other ones they can't change. And its level isn't easy, medium, or hard. It's 0 through whatever, or 1 through whatever. This is an example of that instance initialization block, where I'm doing the work of the constructor for something that doesn't depend on any parameters to the constructor. So every time we create a player, they start off at level 1 automatically, but they all can have a different name. Right? So hence the constructor versus the instance initializer. And it can do 2 things. It can attack and it can defend. It can attack monsters and it can defend from monsters. But we'll see those later. So that's not the interesting part. That's just the setup. The interesting part are these 3 things here, our patterns. So we're going to start off with a monster factory, and this is going to let us create different monsters. It doesn't know about monster because I haven't imported it, right? So we can now have this interface where we can create monsters. So let's make a new easy monster factory. So the idea behind the Easy Monster Factory is that we would have multiple easy monsters, not just rats, and we would pick one of them at runtime to create. So let's go ahead and do this. What we're going to say is, we're going to have to do that. So Easy Monster Factory is going to implement the Monster Factory. And it's unhappy because I haven't implemented that method, which I copied, but I can just be lazy and do that. So here we're going to just return a new rat. Doesn't know about rat because we have to import it. Now, a better implementation of this would be to do a big, to generate a random number and then pick from one of our many easy monsters that we've created. We're not going to worry about that right now. But this is not a very good implementation, but it's a good start, right? So if we made this game, we could we could attack rats, we could attack skeletons, we could attack dragons. Later on, we can improve this code to make it rats or, I know it's another easy monster, mice, right? So we can make that transparent. So simple is good, right? So right now we're just going to return a rat. We're going to do the same thing. For the medium. And that's going to return a skeleton. We'll get rid of the rat. And then we do the same thing for the heart. And that's going to return a dragon. Again, we'll just clean up our imports. Okay, so now the idea is, what we're going to do is we'll just make a game for now. So the game is our main class, and it's going to have a monster, an easy, is it a monster factory? I'll make an easy monster factory. And we will make another thing. So we're going to make a monster. Right, so what I'm trying to do is, I will show you two sets of code. What I'm trying to do is simplify the act of creating monsters. So let's move, this is fine. Okay, so that's how I would use this potentially, right? So I'm going to have something that lets us create a monster. If I didn't have this factory, what I'd have to do is something like this. Right? So imagine a world where we didn't have these at all. I want to return a monster. So first off, I need to say what type of monster I'm creating. So what level? Call it monster level or just level? I call it level. So if or switch level, so we're going to switch on the level, and we're going to say case easy. monster is assigned new rat. I have to import that. Don't forget your default case, always important. I'm just going to throw a runtime exception for now. We'll fix that later. This is throwaway code for this one. Right, so imagine we didn't have any of these patterns, okay? I'm going to say that I want to create a monster of this level. It's going to come in here and do a switch on the easy, right? So if we passed in easy, it's going to go to easy and it's going to create a rat. Or we're going to have to write all that code to do the random generation and pick the appropriate one and all that. So this could become quite large. So the point of design patterns and methods is to make things simpler. So we don't write the same kind of code over and over again. So in this case, what we've got is a easy monster factory that basically does that logic in here to generate the appropriate creature, the appropriate monster. Pardon me. So that would be the same kind of thing here. What goes inside of here is that logic to create the rat or the mouse or whatever. So we've taken the code from this switch statement and moved it into this method. Always good to, the way I phrase things is that methods or code likes to have names, and methods are how we give code names. So this method could become quite complex, but it's going to be 3 times as simple as this huge switch statement, right? Which is going to have case easy, case medium, case hard, and all the math in here, and all the math in there, and all the math in there for dealing with creating all the monsters. So what we've basically said is take this code and put it into this method. Right? So that's what it does. This takes a monster factory and we create a monster. Now I could so if I run this, we'll just print out, so monster, let's just see what that does. I have no idea what this is going to do. Let's take a look. So if we run this, so it tells us we created a rat, right? Not a very interesting way to do that, but okay, it tells us we created a rat. If I change this now to a medium monster factory and run it, now we're creating a skeleton. And if I create it as a hard, it will create a dragon, right? So let's follow the logic of that. We created the monster factory to point at a hard monster factory. When we came in here, the factory is pointing again at a hard monster factory. We just know it's a monster factory, but at runtime, it's definitely a hard monster factory. So we come in here and we say factory create. Well, what's factory pointing at? Factory is pointing at whatever was passed in, which is a hard monster factory. Polymorphism. So we go to the hard monster factory and we see what it does, and it returns a dragon. So it created a dragon. If we'd passed in a medium one, it would have created a skeleton. Awesome. So that works out really well. That's the basic idea of a factory, right? Is that it provides a way for you to abstract the creation of different things just by providing this interface. So a monster factory. Sorry, not a monster factory. A random monster factory is a class that's going to create one of many monsters. So let's go ahead and make a new, let's make this an instance of a monster factory. So when you do this is called an abstract factory. The other one was a factory pattern. This is our factory method. This is the factory pattern, or abstract factory pattern, sorry. So we're going to implement that. probably saner. So, oh, sorry, I can't actually, to make this work, I can't implement the monster factory, my mistake. What this does is it's going to create a monster factory. So this is going to return one of those factories, right? So now what we can say is we can return, so we can do generate a random number. Just get an int. So first off, it helps if we know what that actually returns, and we don't know off the top of our head. So let's see what we can do here. Let's just do a system.println. We're going to assign the value and we're going to print it out and just see what it does, right? So we're going to create in our game now, we're going to create a random monster factory dot create. And this is throwaway code, so it's not pretty, but that's okay. So let's run it and just see what we get for number. We got a really large number and a really small number. Pardon me. Random monster factory. So next int, we can bind it. So we'll say 100, and we'll run that again. So what this is going to do is return a number between, and you can see the numbers here. It's going to give us a number between 0 and 100. Another thing, I'm probably going to take this random, I'm going to make it static. And I'm actually going to make this a new secure random, even more random. The way random numbers work is just through a sequence of math. The secure random's just a different set of math. It should give us a more of a random-esque number here. Let's see. Right, so there's no need to recreate a random each time. That's why I moved it out of the method. There's no need to have different random number generators for different factories. So I just made a static one, so it's shared between all of them. Then I used the static block to initialize it. And then I'm just going to grab the next int. So there we go. We don't need to print this out. All we need to do is say this plus 1, because the value is 0 through 99. This will make it 1 to 100. I don't know if I care about that really. So if the value is less than 33, we're going to return final monster factory. So basically what we're doing is we're creating a random monster factory so that we can then use that monster factory to create a monster, right? So rather than saying always, oh, we're using the easy monster factory, the medium, or the hard, now what we're saying is we're going to create a monster factory. You're going to get an easy, medium, or hard totally randomly, right? So if the value is less than 3, the factory, or 33, the factory is going to be a new easy monster factory. Otherwise, if it's less than 66, we'll make a new medium. And Otherwise, we'll make a new hard. And we're going to return the factory. So back to our game. Here we were having to say, oh, are we creating an easy, medium, or hard? Now what I want to do, go one more step, one more level of indirection, and say that this is a random monster factory. We'll call that our factory generator. And the factory generator is a new random monster factory. And the factory is no longer hard-coded to be this. Now we're going to say it's the factory generator dot create. The factory generator create, and now it's going to create a monster. And we won't know which monster it is. So when we run it, here, let's actually do this. Just so we don't have to run it a whole number of times. Okay, we'll should print out a whole bunch of different things like rats, skeletons, and dragons. So we're getting all rats. That's not good. Which means we're always returning the easy one. Let's see when we run it again. Now we're always getting dragons. And now we're always getting rats. So there's a problem. Always test, right? There's a problem in my random factory. Which seems odd. So let's print this out. Well, that's odd. We're getting oh, my mistake. Sorry. I do need to run that multiple times. What's happening is, of course, I'm creating the factory one. So it's returning a random factory each time. The first time, and then it uses that factory over and over again. So we can't quite do that. So let's actually make our life a little bit simpler. I'm going to move this out of here. I'm going to move this into another method. And we're going to pass it the random monster factory. So all I've done, and again, code likes names, all I've done now is I could have two choices. I guess I can do this. So what I'm going to have it do is actually create the whole monster. I could have it return the factory, but that's not going to save me anything. So code likes names, so I'm just moving some code into a method so that I can make it simpler to understand. So this one, every time I call it, it's going to get a new factory. The problem was I was getting the same factory all the time, or using all the same factory all the time, and I'm going to create a monster from that, right? So we're going to create either a easy, medium, or hard with this, and then we're going to use that one to create the monster. So now this becomes, I'm going to give it that. Sorry, let me just rewind. My method is not static. So just do this. So every time I call this create monster, it's going to create a new factory, and it's going to create a new monster from that factory. So we should get completely random this time. And there you go. You see we get skeletons, dragons, and rats. Right? So it's completely random based on, this one had more rats this time. So I'm going to go back into the random one and remove the print together value. And I'm going to actually show you a benefit of using the hierarchy too. So because I have that abstract method, I can go into the characters and go to the abstract monster. And I can override toString. So you don't have to put the add override, but it's a useful thing to do. If you misspell toString like this, it'll tell you didn't actually override the method you intended to do. So the compiler will tell you if you screwed up. So I'm gonna have this return the name of the monster. So I'm gonna use the or the type dot get name and the level dot get value. Right. So now it should print out that it's a rat of level 1 or a dragon of level 10. And because I did that up in the abstract one that they all extend from, I only had to do it in one place. That's the power of inheritance, right? We can move methods up to the as high as they can go so that everything can benefit from them. Right? So this is different every time because every time we created this random factory generator, every time we call create monster, it comes in here and it creates a different factory, right? Using medium or hard factory. And then from that, it generates a monster. So imagine if we took this kind of code, here, and we had 3 different easy, 3 different medium, 3 different hard. When we run it, we're going to wind up with a dragon or one of the other 2 hard ones, a rat or one of the 2 easy ones, right? So we'll get a much wider variety of creating the monsters. Again, I apologize for having to blow my nose. It's allergies. So all of that, though, from our code point of view, came from that. That's all we had to do, right? Worst case, looking at our code, that's all we had to do, right? Easy, right? Not much code at all, right? We can write in basically one line. We can have any number of monsters created and we won't know what kind they are, right? That's through polymorphism. Right, so now when I run this, I'm going to get a rat. Run it again, I'm going to get a dragon. Run it again, I'm going to get a rat. I'm going to do this till I get a skeleton. Dragon. Rat. Dragon. It's all random, so you never know. There's a skeleton, right? So this makes our code so much better from the point of view of we don't have to litter it with if statements. That's why we write methods. We don't have to, if we wanted to add a new factory, we simply just add a brand new factory. We add a new monster, we add a new factory, we go to the random factory, and we change this math here to say 25% chance of creating the particular one, or whatever we want. And then we just add a new if statement for dealing with the new monster factory. And the rest of the code, this thing, has no idea we added a whole new classification of monsters, right? We could add, so let's go ahead and do this. We'll add just quickly, we'll add a new super hard. This is going to return a dragon. That's not a big deal. So super hard one. And then if we go into the random, and we just change this to 25, 50, 75, super hard, right? And the super hard, is now added. But did we have to change our game code at all? No, we didn't modify it at all. And all of a sudden, it's creating super hard monsters as well. So we have the ability to very easily change our code without having to rewrite all of that other stuff. And that's the whole purpose of those design patterns, to make it so that we don't have to modify our code all over the place. Okay? So the last one I want to cover is the fight. So the fight is an instance of the command pattern. So a command pattern, generally in Java, is implemented with an interface, and it has a single method. So we're going to do void fight. Okay, that's going to take a player and a monster. Right, so we're going to fight with a player and a monster are going to fight. So now I'm going to make a new Java class, and we'll call it. Actually, we could even be smarter about this. We could give it a random monster factory. So we're going to fight a random monster, right? So now I'm going to go new Java class. I'm going to call this a land fight. The idea being that maybe we'd have different modifiers for the player and the creature if they were fighting on land than if they were fighting in water, right? If you're a player standing in water versus a rat having to swim in water, the player probably has an advantage. Whereas if it's on land, there's probably an advantage to the rat because it moves so much faster, right? So, this is the general concept. Right, so we're going to implement fight. So first thing we have to do is generate our monster. In order to do that, we have to generate our monster factory. So now I'm going to back out of this. I don't want to do that. I do want to make this actually a monster because it's easier to test. And if we wanted to make a version that created a monster factory, that provided a monster factory, we could do some other hoops to jump through. But so I'm going to just back out of this because I'll show you in the main method why I did that. But it does boil down to testing. And I guess we need to call this, for sanity, we'll call this monster. We need to import that. And we'll call it monster2 for sanity. So we're going to just make this simple. We're going to say the player attacks the monster. And then we're going to say the player defends from the monster. And we're going to go back to the game. And we're going to not print that out. And we're going to make a player. So I'm the player, sure. And now we're going to do going to make a new method called play. And it takes a fight also notice that I'm not passing in the land fight, I'm passing in fight. That way I can change the fight to a water fight and this method won't change. If I have different kinds of players, again, like subclasses of them, I can just work with any player. And obviously I can work with any monster. I'm not tied to working with rats or dragons or whatever, right? So I do want to keep everything as generic as possible. So we're going to say fight dot fight, and we're going to take the player and the monster. And now we're going to run it. And we're going to see that we're attacking a level 10 dragon and we're defending against a level 10 dragon. Okay, run it again. Attacking a rat, defending against a rat. You can do this for skeleton again. Come on, skeleton. There we go. Right. So the simple thing is I could modify the player. Oh, not here. Sorry, not in here. I could go into the land fight, and I could modify the player. I could modify monster. Right. Just that's that thing where it's like, oh, if they're on land, it's parity, and or the rat has an advantage. The skeleton doesn't. If it's in water, again, there's no advantage to either one of them. And in the case of the rat with the water, the rats would have to swim, and the human wouldn't, so the player wouldn't. So there'd be an advantage. So we do those modifications to set that up. And because we know we're in a land fight, we know how to do that differently than if we're in a water fight. So the general concept is we're going to create a monster and then we're going to fight it in some place, right? So we have no idea what the monster we'll be fighting is. We do know which place we're going to be fighting is. If you're thinking, wait a second, what's the difference between the fight thing and the random monster factory or the monster factory and all that? Nothing, right? They're the same concept. So in this case, because the monster factory has a create method, it's also and only a create method. It's also an instance of the command pattern, right? But it's got a different function. The command pattern is there to basically just say, I want you to run this bit of code. And in the case of a abstract factory, the random factory, what it does is its one task is to create a factory. So it is an instance of the command pattern, but the intent is different. So the intent of the abstract factory is to specifically create another kind of factory. That's all it does, right? Whereas a general command pattern, it can do anything. So it's not limited to creating anything. It's not a creational pattern. It's what's called a behavioral pattern. So they're very similar, and lots of the design patterns are, right? You'll see lots of similarities between them. So this hopefully gives you an overview of the concept of design patterns, shows you that you can make your code smaller by using design patterns, and shows you a lot more about hierarchies and polymorphism, right? We've benefited a lot from polymorphism here. For example, polymorph and inheritance. For example, when we went into the abstract monster and we added the toString, and it started working for all the subclasses at once, right? As long as we're happy with that toString, a subclass doesn't need to override it, and it's good for all of them, right? So that's a huge benefit. We're saving a bunch of time. The other thing is that we're trying to make little methods of things, right? So if you imagine you had to do all that work inside of the game, it would be quite ugly, because you would see all of this kind of stuff, right? You would see the huge bunch of math here. You would go into these factories and see the same kind of math there, right? So this allows us to easily test things in isolation. It allows us to logically break things up. It allows us to easily find out things where we want to find them. And it ultimately makes our code. I don't think we need this anymore. Nope, we do need that. But we don't actually need that. So you can do overkill with these things. So monsters assigned factory dot create. You can go a little bit overboard. We don't need that once we change the code. So the code here is a lot smaller than if we had not used the design patterns, because the design patterns disperses the code into different places, which makes this code easier to read. Right? You do have to jump around more, right? Like when you come into, if I ask you, what is monster going to be? All you can tell me is that it's going to be a subclass of the interface for a monster. You can't tell me which monster it was. In order to figure that out, you'd have to go to the create monster function or method. Right? And create monster, well, you'd have to figure out what factory got created. So we'd have to go here. And here you go, I have no idea, because it creates one of many. And that's how you know that you're dealing with polymorphism. Two things. We're dealing with an interface, and we're dealing with different things being created. So that right there tells you it's polymorphic. Once it's polymorphic, you can't tell me what it produces. You can tell me what kind of thing it will produce. So all we can tell is that it's going to produce a monster. And all we can do with monsters is get their level and get their type. Obviously, if this were a real game, we'd want to have more things like, you know, the ability to add armor and weapons and what's the attack strength and the speed and all that kind of stuff. But we're not doing that to keep things simple. But, you know, do we care what kind of monster it is? No, all we care is, you know, that we can attack it. It can attack us. And how much damage do we do and all that. But we don't actually care if it's a rat or a dragon. We're just getting attacked or attacking. So hopefully that gives you some inspiration for your assignment. You don't actually need to use it for the assignment, but you can hopefully see how it applies. And we will make use of some other stuff in lab later on. Have a good day.